Hi, welcome back to this course on capital budgeting. In the past videos, we have seen NPV, payback period, IRR, and some limitations of IRR and other investment decision rules. In this video, we are going to give you another example of different options in investments. Usually in normal investment, you have outflow first and then the inflows, right? In this case, in this example, we are going to check an option where you have inflows first and then the outflows. How does it work in those kind of scenarios for different investment rules? So if you see the screen now, you have a problem with the delayed investment. Means you have a choice that you are gonna get a $1 million upfront, and then you have to pay uh, $500 per year in 2 years. So that's the option. Either you get a single payment of 1 million now, or you get $500 at the end of every year for the next 3 years. So what is the better way? You wanna accept the $1 million today, or you want to accept $500,000 for the end of next 3 years per year. So the timeline for this decision is 1 million minus you receive it now, so that's the cost of investment. $500, 500,000, it's going to be outflow for the next 3 years each year, right? So now the opportunity cost of capital is 10%. So first process would be to calculate a net present value. So we will calculate the net present value for the next 3 years of $500,000 each. That will comes to like this. That will comes to the and the IRR for this is going to be 23%. The NPV for this method is let's see NPV of the method is 1 minus 243,000, which means that we are getting more income, right? In the we are paying more, so we should be getting. So what should be the decision? We should be getting we should be taking the money now, or we should be paying in 3 years. Definitely from the NPV point of view, we should be paying in the next 3 years. We should not get the money now, right? But the IRR method says that option A is better because the return is 23.38%. There is a policy because it's a reverse method, right? So in this case, higher IRR will denote a lower investment. The wrong decision. To resolve this, let's draw the NPV profile, and then you will see another picture. So the NPV profile at different at 10% is still negative, right? But we are accepting the decision. And at the IRR is 23%, it's zero. More than 23% will give us positive result. So here in this case, you can see that IRR is giving a opposite result compared to the NPV method. So that's why we normally follow NPV method. Here is again another dimension in the equation where you have an additional payment of 600,000. So means you get 1 million now, 600,000 after 10 years, and then you continue to pay the same story, 500,000 for the next 3 years. In this case, you will get multiple IRRs. How? Let's look at that. So the new timeline here is in the first year you get minus 1 million, then you get $500,000. You have to pay $500,000 for the next 3 years, and at the end of the 10 year you are gonna get 600,000, right? So the NPV in this case will become positive, right? But uh, if we plot it on the NPV profile, you will see two IRRs. Why you will see two IRR is because there are two positive signs and three negative signs. Whenever there is more than one negative signs, or more than one positive signs, i.e. the investment is 2 times, you will get two IRRs, because at both the IRRs the NPV will become zero. So here, as you can see, the IRR is positive at less than 5%. Cost of capital is 10%, is still negative. And at 13% it becomes again negative, right? And then it goes up. So what is the scenario in this case? At 10% cost of capital you are still minus 12,000, but now you have two different IRRs because you have two different positive signs. That's the problem with the IRR method. It gives you two IRRs if you have multiple positive points, right? To avoid this, normally we calculate a modified internal rate of return. So modified internal rate of return means we modify the formula for calculating the IRR itself, and then we get a modified IRR. So how we do that? We do that by two methods. One is we modify the cash flows to zero. So one is there are two ways. One is either we bring all the negative cash flow to the present, so all the future negative cash flow or positive cash flow to the present date, and leave the positive cash flow, so you have only one negative cash flow, right? So in this case you will bring 600,000, which is at the end of 10 year, to present value first, and then you will calculate the IRR, so you will get a different result. And or otherwise you leave the initial cash flow alone, compound all the remaining cash flow to the first period of the project. So it means you have only two cash flow. One is initial, and then you will present compound all the cash flows to the final periods, not the first period, final period of the project. So in this case you will compound every year to the next, and then you have only two IRR. One is at the year one is at the final year plus, and then you will calculate the IRR. In this case also you will get only one, but it does not remove all the technical problems of IRR. It still remains the same because the modified internal rate of return again follow the same principle that every investment is going to be every return is going to be reinvested at the same rate as IRR. So the problem remains the same. It is advisable to modify the cash flows. It's not really the internal rate of return. It does not solve some of the problems when choosing among different projects, i.e., it does not take away all the internal inherent limitations of IRR formula.